I hope that by the end of the talk you have some vague idea of how JSON Web Tokens work and how you can use them to make it easier for yourself to authenticate or do things with identity on the internet. So let me quickly introduce myself. Okay, my name is Sam Bellen, and I was surprised that he pronounced my last name right, because usually I get a lot of strange ways of pronunciation. I'm a developer evangelist at Auth0, and if you've never heard of Auth0 before, we're basically an identity as a service provider, which means that we try to make it as easy as possible for developers to integrate with us, so you can focus on building your actual product instead of building an authentication and authorization server. I'm also a Google developer expert, and I organize a few meetups, one in Belgium and an identity and security meetup in London. And you can find me on the internet as Sam Bellen. So, most important slide of this presentation, I have cat stickers. So if you want a cat sticker, tweet me a picture of your cat, your dog, your bunny rabbit, whatever you want. If you don't have an animal, just tweet me a picture of an animal, and I'll give you some cat stickers after this talk. Who wants a cat sticker? I want to see more hands, but it's okay. So tweet me a picture of an animal, doesn't matter what, and I'll give you some after this talk. Okay, let's get started. I'm going to be talking about three things today. The first one is traditional authentication, or at least what I view as traditional authentication. I'm going to try to explain what a token is, and in detail a JSON Web Token. And I'm going to be talking about token-based authentication. So traditional authentication, what I mean with this is a scenario where you have a web app which is being generated on the server. So the server does all the logic, all the heavy lifting, and if you want to authenticate, it's also handled by the server. While as a single-page application, which we're going to be talking about later, it usually has a lot of logic in the front end. It's all JavaScript loaded by the browser and executed by the browser. So there's a bit of a difference between those. And you have your typical scenario: a user navigates to your website in a browser, and the browser does a request to a server to get a certain page. But sometimes these pages are protected because there's data on that page that not everybody should be able to see, right? So the user has to authenticate. It has to give you some way of authenticating, usually a username and password, or email address and password, and types it in the browser. You pass it along to your server, and if the credentials match, you give that page to the user. I think we've all done this before or seen this before. It's a very common thing, but it will not only pass that page to you, it would also, in a lot of instances, give you a session cookie, which is a cookie that will be saved by the browser, so that each time that you want to access another protected page, you're not going to have to log in again, because that would be annoying. So it's the next time you want to access a protected page, you just send along this cookie in the background, and if the session in that cookie is still valid, you can just get your page back. Does this sound familiar to most of you? Yeah, okay, cool. So a traditional web app versus a single page application. There's some differences. A traditional architecture is mostly tightly coupled between your web app and your server, because your server generates that web app most of the time. Can be multiple servers if you have multiple instances, but it's still the server that does most of the heavy lifting. A single page application can look a bit like this. You have an application which runs in the browser and which can talk to multiple APIs. It can talk to your general API, it can talk to a separate API for your user management or for your identities, it can talk to a separate API for payments and most of the other things you can think of. So it's already a different thing. The browser does most of the heavy lifting. It just connects to an API to get some data, or to store some data, to do something with data. You also have something like this, where you have a mobile app, a desktop app, maybe, and also a web app who's working on a product or has worked on a product that has something like this, like a web app and something else. A lot of you, I guess so. The funny thing is that using a cookie is something that is inherently proprietary to the web. You will not use a cookie if you want to authenticate on a mobile app or on a desktop app or a CLI app. It's something that's been used by a web browser and by a web browser only cookies. So it would be nice if we could authenticate more or less in the same way with all these kinds of apps with our authentication server or API. So this can create a problem when using cookies. So what are some of the problems with the traditional cookie-based approach? Cookies don't like CORS. Who likes CORS? Nobody likes, no, you're lying. Because most of the time when you get a course problem, you go to Google, you type in, I have a course problem, and you end up with Stack Overflow, and you just copy whatever in that one message that's on there, and your course problem is solved. But nobody really likes course, including cookies. Cookies require state, because most of the time, in these session cookies at least, there's a session token, which is something that you save in a database, and it has an expiration date, but you have to keep a database of all these valid sessions. And if we're working with APIs, the most ideal scenario would be that we have a stateless API. So cookies require state, at least session cookies. And cookies don't flow. You cannot pass a cookie, or the content from one cookie from one server to another, because a cookie is issued by a certain domain, a certain server, and not by the others. For example, if your main API wants to get something from your user account API, it cannot just pass along the cookie or the session from that cookie to another API unless they have a shared database. But the cookie itself is issued to the first API, not the second one. So you cannot really pass them along to other services. So what else is the solution? Maybe it's token-based authentication. And what it is exactly, we're going to see later in this talk. But first we need to talk about what is a token. A token, at least according to me, is a unique identifier representing something. So as long as you can take this token and get some meaning out of it, to me that's a token. It can be a lot of different things. For example, an access token. Who's ever heard of an access token before? Who's ever used them? More or less the same people? Okay, cool. An ID token, same question. Who's ever used them? Refresh tokens, more or less the same people. These are three of the most commonly used tokens when working with authentication and authorization. And what some of these are, I will explain later. But they're often an opaque string in the form of a UUID, which means that it's just a seemingly random string of characters and numbers and symbols or whatever. But there's not really a meaning behind it other than you've saved it in your database and you know that it's valid because it's saved in your database. It sometimes can be XML, like a SAML token, if you're familiar with the SAML protocol for single sign-on, mostly in older enterprise architectures. It's a bunch of XML which has some meaning to it, it has some content in it, but by passing this SAML token, you can also prove identity or that you're authorized to access a certain resource. And they can also be JSON Web Tokens, which is what I want to be talking about today. At Auth0, we use JSON Web Tokens a lot, mainly just because we like them. That's the reason. So this is a JSON Web Token. Who of you have noticed before that a JSON Web Token is actually made out of 3 parts? Wow, a lot of people. Good. So if you look at this token, it looks like a bunch of random characters, right? With 2 dots in them, one in the beginning where the red part stops and the purple one starts, and one at the end where the blue part stops. And these 2 dots are basically just the separators between the 3 different parts of a JSON Web Token. And the first part is this part. And it looks like random characters, but basically this is just a base64 of a JSON object. And it's called the header. And the header of a JSON Web Token just contains some metadata about the token itself. Which algorithm has been used to validate or to sign this token so you can validate it later on, and what it is. The type is a JSON Web Token. So JSON Web Token tells you that it's a JSON Web Token. Just for convenience. So this little part, if you would just go to base64.com or whatever you want, put it in there, would result in a JSON object. The same thing goes for the payload, the middle part of your JSON Web Token. It's also just a base64 of a JSON object, which contains a bit more of information that you need to use this token, or you can need to use this token. For example, the subject, which is your user ID, your given name, family name, your username, when it's issued at, so an issued at date, and also when it expires. So one of the cool things and convenient things of JSON Web Tokens is that it can also contain an expiry date. So when you parse this content, you already know if it's expired or not. And there's a bunch of different claims you can put in this payload. A claim is just a key-value pair. And the first one are reserved claims. And a reserved claim is basically just anything that's been mentioned in the spec of JSON Web Tokens, like subject, issuer, issued at, expiry date, and stuff like this. The second one are public claims. These are not necessarily mentioned in the spec of JSON Web Token, but these are standardized in a way. So if we go to this web page, not this one, it's a web page made by IANA, which is one of the organizations on the internet who try to standardize stuff. You'll find a whole list of claims which you can use in a JSON Web Token just for API interoperability. So if you're making an API and you're making an API, you know what to look for in a JSON Web Token. If you want to use a first name, you're going to use given name, not first name. If you want to use a last name, you're going to use family name, and so on, just so that you can expect the same claims from multiple different vendors and APIs. You don't have to do this, but it makes your life a bit easier and everybody consuming your API or your tokens as well. And then the last set of claims are just private claims. And this is basically anything you feel that is important for you to use a certain token and you want to put in a token. As long as it's valid JSON, you can put it in there and run with it. So we've seen the header, we've seen the payload. The last part is the signature, and this is what will allow us to verify that the content of this JSON Web Token has not been tampered with. So you usually take a signing algorithm, the one which has been mentioned in the header, take a base64 of your header, put a dot, take the base64 of your payload, and then a secret in the case of this algorithm, and you run this function on this data, and it will give you a signature, which means that if something in your payload or header, most of your payload would change, the signature would not match anymore with the one being issued before because it's related to the content inside of your JSON Web Token. So a JSON Web Token can be verified. You can know without looking something up that a JSON Web Token is still valid, that the content has not changed. You can also know that a JSON Web Token has expired, for example, because it can contain expiry date. So you don't really have to keep that database with all valid sessions anymore if you're using JSON Web Tokens, because most of the content, or all of the content you need to verify its validity, is embedded inside of a JSON Web Token, which makes them very convenient to use. Your signature, it's the same slides, is often your secret is something random, but it is just if you use this algorithm, some other algorithms use a private and public key. We'll get to that later. So if we would take a base64 of our header and of our payload and then run this magical signing function, we get a JSON Web Token. And if we copy this and go to jsonwebtoken.io, which is a website that we created at Auth0, but it basically allows you to inspect and debug JSON Web Tokens or create JSON Web Tokens. Paste it in here. You would see that my content, my payload is the same, except I made a bug and there's no space between my first name and last name. But you can just decode the content we just made, we just used earlier, because it's a valid JSON Web Token. So some real-world examples of JSON Web Tokens. An access token, because a lot of you have used them before, and they can be just a UUID in opaque string, because if you're using access tokens, you're probably using the auth framework, and they don't specify that an access token needs to be a JSON Web Token. It can be anything as long as it's useful to you. But you can use a JSON Web Token for that. And it would look something like this. The issuer, which instance has issued this JSON Web Token or this token, for who it is meant to be, your subject, your user ID, which audience, when it's issued, when it will expire, which scopes you want to grant access to. So if you want to grant access to certain parts of your application or API, and not all of it, which is often the case, you can also already mention them in this JSON Web Token, and you can use them on your API when you validate the token. The same goes for an ID token. It contains some information about my identity, my nickname, my real name, where you can find a picture of me, and when it expires and stuff like this. This means that when you have done your authentication, you don't have to do this extra request to a user info endpoint or whatever you want, because you already get this ID token back and you can show my username directly. You don't have to ask for this data in a second request or in a third request, which makes it also very useful, because you know who you just authenticated. Not that you just authenticated, but who you just authenticated. If you want to do it in JavaScript, you just take crypto.js and take your base64s. It's not that important. But up until now, we've seen symmetrical algorithms, which take a secret to sign your JSON Web Tokens. There's also a bunch of asymmetrical algorithms, the one in black. and they use a private and public key. So they're usually a bit more secure. But if you leak your private key or your secret, you're fucked anyway. So the bottom ones of these, they use a public and private key. And usually you want to share your public key so other parties or even internally other servers can validate your JSON Web Token based on this public key. And if you want to share those keys, there's a bunch of different techniques. One of them is a JSON Web Key. So you have a JSON Web Token, now you have a JSON Web Key. A JSON Web Key just contains all of the information you need to validate the signature of a token signed by a private key. Contains this information. And if you're using the OpenID spec, you can often find where to find this key because according to the spec, there's this well-known /OpenID configuration path in your authorization server, which you can visit. And it looks like this. And it has a bunch of information about your configuration and the possibilities of your authorization server. And one of them is the JWTs URI. And if you click on it, you can get your one public key or the multiple public keys that are being used so you can validate against them. So they're publicly available to anybody because you always want to validate a signature, but nobody can use this to sign because you need a private key for that. So that's very convenient. The well-known /JWTs.json, it can be something else, but it's often this URL. If you implement the OpenID spec, it's the one we saw earlier. So you have JWT, JW key. There's also JWS, which is a JSON Web Signature, which is basically the bottom part of a JSON Web Token. I'm not going to talk about that much. There's also JWE, which stands for encryption. If you want to encrypt everything in your JSON Web Token, you can use this standard for that. Not going to focus on that either, but it's good to know that there's a bunch of JSON Web standards out there which try to make it as easy as possible for us developers, especially on the web, to do things with signing and encryption and stuff like this. So let's make a little comparison. On the left, is it left? On the right, we have a Belgian passport written in 4 languages because Belgium. And on that passport it says, I'm a passport of the European Union from the Kingdom of Belgium. So it tells you what it is. And you can basically just compare this with the header of a JSON Web Token because the header of a JSON Web Token tells you I'm a JSON Web Token. I have this algorithm that's been used to sign myself, but it tells you what it is. If you open that passport, you see some information about yourself, about myself, about the identity of the person that was issued this passport. My name, last name, nationality, my expiry date. And it's kind of exactly the same thing as the payload of an ID token. It tells you who it's for, whatever you want to know about him or her, when it's issued, and when it will expire. So the payload of an ID token is more or less the same as the inside of your passport. And then the signature is something that lets you verify that it's a valid JSON Web Token. And any passport has a number of ways to be able to tell if it's a valid, if it's a fake or not passport. Like some UV lights thingies or fingerprints or whatever. So in essence, a ID token in general is more or less like a passport. It's issued to somebody, so it's linked to an ID, and it gives you access to something, or it tells you that you gave access to your system. So let's see it in action. I have, if all goes well, a little web app set up here. And there's basically two knobs, 2 buttons, one to show you a random picture of a dog, and one to show you a cat. But if you know dogs and cats, dogs are easy, cats are sometimes a bit more difficult. So they require you to log in. That's no problem, because I work for a company that does authentication as a service. So we'll do that. So it asks me to log in, and I'm lazy, so I'm just going to use my Google. Whatever, but once I'm logged in, I'm able to do this thing and get cat pictures randomly. Seems to be the same cats over and over again. I was hoping to get to my own cat, but all right, this is my cat, just as a reference. So we have this very simple web app that has 2 capabilities, either authenticating and show you pictures of dogs and cats. Of course, there's an API for this as well. So, oh yeah, I could not maximize the screen either. So we have our API here, which has 3 endpoints. An authentication endpoint, which basically if you post your username and password, don't use this as a password ever. I don't think I have to mention this. But if we do this, we get a JSON Web Token. If you want to get dogs, you just send a request, and because it's a public API, you can just do this without any authentication. But if you want to do this with a cat, you will see that it throws an error, no authentication or no authorization token was found. That's because we have to take this JSON Web Token that we got when logging in, which is our access token in this case, and pass it along as a bearer token. And once we give this token, we have access to this resource. I think that most of you have done this already before, right? Or is this new to anybody? Okay. So what's the difference between using just a UUID as an access token or a JSON Web Token as an access token? If I would, for example, pass along an expired JSON Web Token without even doing a second request in my database or lookup, I know that it's an expired JSON Web Token because JSON Web Tokens have the expiry date in them. The same goes for if the signature is invalid, which means that something in the payload has changed and the signature doesn't match anymore. It will tell us. So without doing some extra lookups in the backend, doing some database requests, doing some whatever you want to do, your JSON Web Token tells you most of the information why something or the token is valid or not. So you can kind of trust on the information inside of it because it's signed. So if you want to know more about JSON Web Tokens, jsonwebtoken.io, the site I showed earlier, it has a lot of information about it. It lets you debug JSON Web Tokens, and it also lists a whole list of libraries in a bunch of different languages, including Node, if you want to use it and don't want to write too much code, because we're all lazy in the end. So if you're interested, go to JWT.io. But let's move on. So are there any downsides to JSON Web Tokens? Anybody in the audience here who has been thinking, sounds cool and all, but... Yes, sir. I don't think that's inherently something with the JSON Web Tokens, but more or less with the... But I think it's more an issue with the authorization server than JSON Web Tokens in general, because SAML tokens are XML, which are...
Talked about in terms of authentication rather than authorization.
Authentication, yeah. Authentication as well.
There's a lot of people in this who don't quite work exactly the way it works, and there are fights between whether it should go with SAML or...
Yeah. In my experience, or to my knowledge, SAML is a bit outdated. It still works. It uses XML instead of JSON, which JSON is a new cool kid in town. Doesn't mean that XML is not good, but SAML tokens are usually a bit bigger because of XML. It's just you require a bit more boilerplate. So if it parses faster than the JSON Web Token, I think that might be related to some other things, not the JSON Web Token in general. So I cannot answer this for you. But if we want to look at some other downsides, or at some downsides of JSON Web Tokens, the invalidation of a token is a bit harder. Let's say that I hired this person on Monday morning at my company, and I give him access to my email and my CRM and my ERP systems, and he's logged in and all of this. So I've issued him a JSON Web Token, which is valid for maybe the rest of the day or the rest of the week, depends on when your expiry date is. But I decide that I don't like him that much, so I fire him after an hour. It means that he still has a JSON Web Token that's valid for the rest of the day or the rest of the week. So technically, he could still access our systems while he's been fired already. So if you want to invalidate the JSON Web Token because of some reasons, you'll have to build a blacklist or a whitelist, which means that before validating the JSON Web Token, you'll have to do a lookup in a database, a blacklist or a whitelist, just to see if you didn't revoke that JSON Web Token, because there's no other way of revoking JSON Web Tokens since they contain all of the information needed inside of them. The same thing is if you leak your secrets or keys, like I said earlier, you're fucked. So that's also a downside, but I think people working with secrets and keys usually know how to hide them or store them securely. If not, they should not be working with secrets or keys. So those are two downsides of JSON Web Tokens. As a reminder, never put any sensitive data inside of the payload because it's just a base64 of a JSON object, which means if you put a credit card number in that, everybody can just take that payload, run it to a base64 encoder or decoder, and get your credit card number. So don't put anything sensitive inside of that token. Okay, so we saw the traditional approach to authentication. Now we're going to look at token-based authentication. Same story, user, browser, web app. You want to access a protected resource, so you send your credentials to your authorization server. And once they check out, it sends you an access token instead of a cookie. It is a little difference. We're not getting a session cookie back, we get an access token back. So we can use this access token in the future to do other API requests to protected resources. And then get our data back. That's what we did. If you want to do it in JavaScript, it looks like this, but you're all JavaScript developers or Node developers or stuff, so we're not going to look into this. But usually you use some kind of framework to use a token-based approach. So who's been using OAuth before? Okay, so if we look at the definition of OAuth, OAuth 2.0, in this case, is a protocol that allows a user to grant limited access to their resources on one side to another side without having to expose their credentials. Who's been using OAuth to authenticate people? A lot of people do, but I just see two hands, which either you all do it perfectly or you're afraid to say so. OAuth has never been meant to authenticate people. It's all about granting access to certain resources which the user has to give permission to. Like if I'm LinkedIn and I want to send emails to my Gmail contacts, I log into Gmail, I give them access to view my contacts, but LinkedIn cannot do anything else except viewing my contacts just because when logging in, I got this pop-up window which asks, would you like to give LinkedIn permission to see your contacts? So OAuth is more a framework of giving limited access to your API or to from one side to another, not about authenticating. On the other hand, OpenID Connect, who's used it before? A few people. So I saw a lot of people using OAuth and a few people doing OpenID Connect. So either you were lying before or you're really just doing it for authorization. So OpenID Connect was created as an identity layer for OAuth 2.0. And this is the most important part. If you want to authenticate, if you want to work with identity, you're going to probably have to use OpenID Connect or something proprietary, because the OpenID Connect just adds an identity layer on top of the already great standard OAuth. And it might look a bit like this. For convenience, we split our authorization server and the rest of our API. So we request access, we send our credentials. You will probably get redirected in your browser. You enter your credentials. If it checks out, you get back an access token and use that access token. Or you can also sometimes get an ID token or refresh token. You save them in memory, and whenever you need to do a protected call to a protected resource in your API, you're going to use that access token and get your data back. Does this mean that the user will have to log in every time that it does a protected resource? Because I said before, we're going to store these tokens in memory, not somewhere persistently like in local storage or a cookie, which you might find on the internet a lot. But of course it doesn't, because there's some ways around this. So the login flow stays the same. The user logs in, enters credentials, and we get back our tokens, the ones we need. Often with single page applications, usually that's not a refresh token, but an access token and or an ID token. And we also get back a cookie, so we're back in the beginning. It's a cookie-based approach. So we save these tokens in memory, we save this cookie in the browser, and every next request we do, we will, in the background, usually in an iframe, send this cookie to our authorization server and get new tokens, and by the time your app has bootstrapped, you will have your tokens hopefully ready. So we send this cookie in the background, and once that session and that cookie proves to be valid, you get your tokens and you can save them again in memory. So every time you refresh or the user returns, you're going to do this silent authorization request in the background, often in an iframe, with this cookie, which eliminates the need to save your tokens somewhere persistently in your browser. Because if you save them in local storage or a cookie or whatever, vulnerable to XSS attacks, cross-site scripting. And you might say, like, I've done all the necessary measurements to prevent XSS on my website, but who of you uses NPM every day? And who of you checks all the packages you pull in from NPM every day? Nobody, right? Almost nobody does this. So any of the packages you use from NPM, or any other package manager for that matter, could contain some malicious code that is trying to steal your tokens from your local storage, session storage, IndexedDB, cookies, whatever it can access. So it's never a good idea to store these tokens inside of something persistent, but keep them in memory. Our token is your token. And then use your token. Now this is using the auth implicit flow. And in recent days, I think since September or December, I forgot, there's a bit of fuzz about this flow because it's a very rudimentary flow. It's just you ask for a token, you get a token. There's a bunch of security implications involved with this, which can all be, you can work around them. You can protect yourself to most of these vulnerabilities, but there's a bit of a fuzz about it. And the Internet Engineering Task Force, the IETF, has published a new best practices document stating that you should try to avoid the implicit flow if possible. If not, do the necessary measurements to prevent most of the vulnerabilities, or whatever you pronounce it. But use the authorization code with proof key for code exchange, PXE for short, flow, which is a bit more complicated. It looks like this. First time you're going to authenticate with your authorization server, you're not only going to enter your credentials or ask for the credentials page, but you're also going to send a code challenge from your web app. And it will send you back a code. So this is the same as a code flow in auth. And you will take this code and send it back together with a code verifier, which is something that your web app or your framework can generate. And based on this code you send first and this code verifier, it can kind of figure out that you're the same person who asked for that code in the first place, because they're all generated from probably the same private key. And if these two match, then you will get your tokens back. So it requires a few more steps, but like with this flow, your authorization server can be sure that the person or the client who asked for the code in the first place is also the client or the instance that you is asking the tokens with that code in the end. So a note about refresh tokens and single-page applications. Using refresh tokens in the front end should be avoided. If you use the iframe technique that I told you earlier, you don't really need a refresh token because you will issue new access and or ID tokens every time the user visits your website. Should you want to work with refresh tokens anyway in a single-page application where everything happens in the front end, use a system where you rotate your refresh tokens. So your authorization server will issue new refresh tokens once in a while or every time you do a request to it. Or use sender constraints, but there's not really a technique at the moment which lets you do sender constraints. It's just thinking ahead of the future. So try to avoid refresh tokens unless you really want to. Use token rotation. So, does this token-based approach solve for CORS? Who thinks it does? This one brave soul? I think it does. Because as long as you can validate a JSON Web Token, doesn't matter which domain you're on, which server you're on, you can validate it, you know it's valid, so you can pass those tokens along to different domains. So in theory, you don't have CORS problems anymore. Does this approach solve flow? Who thinks it does? Two more brave souls? It does, but because again, you can pass along these tokens to anybody who needs them as long as they know how to validate them, it should be fine. And does this approach solve keeping state? Who thinks it does? A few more people, and technically you're right, because the JSON Web Tokens contain most of the information or all of the information needed to verify them. But if you want to be more secure on the web and don't store these tokens somewhere persistently, you need a session cookie again. If you want to have a blacklist so you can invalidate tokens, you need some state again. So in theory, you can invalidate them. In practice, you can not really. So keeping state is still somewhere in the middle. So let's summarize. Using session cookies is hard with single-page applications unless you only use the session cookie for your authorization in the background. Stateless authentication is possible unless you want to do some fancy things in iframes or want to keep a blacklist. And JSON Web Tokens consist out of 3 parts: the header, the payload, and your signature. These are a bunch of resources if you want to know more. JSONWebToken.io. If you're interested in the Web Authentication API spec, which I didn't talk about today actually, we have a website about this. There's a whole blog post about why the implicit flow has had some issues and why they chose to use the Pixie flow. And our blog is also full of other resources. If you want to see these slides again, jwt.sambega.tech. I'll tweet them later as well. Any questions? You wanted to take a picture? Go ahead. Yes, sir.
I guess, how much information should you be storing in an ID token? And why would you sort of prefer that instead of using an access token to some sort of other like ID service you might have?
So the question was, how much information should you put in an ID token, and what's the difference between an access and an ID token?
Well, why would you not use an access token to some other ID service?
Okay, so why would you not use an access token to some other ID service? First of all, you put as much information in that ID token as you want, but bear in mind that the more data you put into it, the larger it gets, and you have to send it along to, it gets larger in general because there's more data into it. So I would only put the data into it that's really necessary for me to use as soon as I'm authenticated. That's usually your username and sometimes an avatar, so you can already broadcast this. And all other data that's not really necessary, you can fetch afterwards again. Then an ID token is something that's being used by the client, the front end. An access token is something that's being used by the back end, by your API, your services, whatever. So you should never use an access token on the front end and an ID token on the back end. That's why there's a distinction between the two of those. Your backend doesn't really care about your username or your image, but it does want to know your user ID, your subject, while in the front end, you don't really care about which scopes you get access to and stuff like this. So they're both used in different use cases. Does that make sense?
Yeah, that's great.
Okay. Any other questions? Yes, sir.
Because of the invalidation is one of the downsides of the JWT, what would be the recommended expiration time of the token? Maybe 10 minutes or an hour?
Of course, most of you probably don't let your access tokens be valid forever. And if you do, think twice about that. But an access token usually is not valid for that long. I think in our system, by default, they're valid for 10 minutes. So they should expire recently fast, but that's up to the person implementing it or using it. So if you use an access token that's valid for a week, you run into those problems. 10 minutes, you don't really have that problem. But that's really just up to the person's building the system. But yeah, a token should not be valid forever, definitely. Yes?
So when you have short tokens, surely you need some kind of refresh token to get a new token once it's expired. Or how do you handle that?
So the question was, if you have tokens which expire reasonably fast, you need a refresh token. So yeah, either use a refresh token to get new tokens when your access token has expired, or you use the technique with the iframe that you get new access tokens every time you refresh based on that session cookie that you send, that you save in your browser and send in the backend. But like I said, if you want to use refresh tokens, the recommendation these days is don't store them in the browser, so don't use them in the front end in a single page application unless your authorization server knows how to rotate these, so how to change these once in a while. Because most authorization servers, including Auth0, have refresh tokens which are valid for forever. So unless you can do something like this, try to avoid refresh tokens and use a technique like the iframes, which also has drawbacks. Like in Safari, it might sometimes get blocked because it thinks that you're tracking them through iframes and stuff like this. So the ideal solution is rotating your refresh tokens, but most authorization servers don't support it yet. Yes?
Can you elaborate on how using a session cookie to retrieve your token protects you from cross-site script?
Let me try to get back to the diagram real quick. Okay, so you will have to allow a course header on your API or on your authorization server from this page in the background, because usually a single page applications are run on a different domain. If you're on the same domain as your authorization server, there's no problem at all because you don't have course. If you're not on the same domain, you will have to allow this one domain, this one origin on your authorization server to do requests to it, which is then usually either your domain of your single page application or some other domain which you use inside of that little iframe. So you don't run into course problems. Yeah. Was that clear? Yeah. Okay. Another question? Okay. Yeah.
Would you use a reverse proxy to solve the course problem through the single page app to your authentication?
So you asked if you could use a reverse proxy to solve the course problems. Probably. Yes. All right. I think we'll leave it to the next speaker. Thank you.